What is up, guys? Fahir here from Tuts.com, and this time we are back with a 2D space shooter game. It's a simple game aimed at those who are just starting with game development. If you followed my from scratch to game tutorial and you went through my C# tutorial series, this is the nice game for you to watch. So before we start creating it, let's see what we are going to create. Now, as you can see, it's a very simple and small game. We have a spaceship that we can move up and down. He's being animated. We have enemies that are shooting him. We have a scrollable background. So nothing too complicated, and I can shoot the enemies, you can see, and I can destroy it. I can also destroy these asteroids. I'm not counting the score or anything. I made it very simple. So as you can see, we have simple animations. We can destroy these asteroids. We can destroy the enemies. They can also destroy us, so we need to be careful when they shoot us and get us caught with the bullet. So yeah, anyways, this is it. This is our simple game. As you can see, our asteroid killed us, so we touched it and it killed us. I'm not even restarting the game. I'm giving you assignments, which is really cool. In this tutorial, I'm giving you assignments on what to do. I'm giving you advices how to proceed to tackle that assignment that I gave you, and I want you to finish those assignments and show me in the Facebook group. So before we also start, you can download this complete project, and the assets link will be in the description below or on my website awesometudes.com. Subscribe to the channel, turn on post notifications, and let's get started. I am in a new 2D project. I named it 2D Space Shooter. You can name it however you want to name it. And of course, as always, the first thing that we are going to do is import the assets. So we only have sounds and sprites, and in sprites we have a couple of more folders. We will see that, but simply select them and drag and drop them right here in Unity, and it will import them. These assets, along with the complete project, are available for you to download. Link is in the description below, or from my website. I'm having troubles speaking. From my website, awesometudes.com. Let me just go here in the scene and quickly change this to gameplay scene, because we're only going to have one scene. It's going to be gameplay. And the first thing that I want to do is create the background. Now, in order to create the background, first I'm going to right click here in folder, and I'm going to say materials, and we are going to create a right click, create. And here we have a material. This is going to be our BG material. And we are going to, let me just go here, standard. Can I use something like maybe unlit texture or legacy? And I'm going to say diffuse. Yeah, this is okay. So legacy, shaders, diffuse. We can also use, for example, your unlit texture. It does not matter. We only need the tiling here and the offset actually, because we're going to offset this background to, well, make it seem like it's an infinite background. And let me go here quickly inside of our hierarchy. I'm gonna right click, go under 3D object, and we need a quad. And voila, here is a quad. As you can see, this black thingy. Let me just reset the position. So right click on the transform and reset the position so that it is in the center. And I'm gonna take the material and I'm going to attach it right here on the quad. Voila. Now we do have this white thing, so what we are gonna do is click on this material here to unfold it, and let me go here in sprites and BG, and here it is. Since this project is created as a 2D project, Unity will treat these UI elements as UI. So they will treat them as sprite and UI, but what we need to do is we need to put them here on default. So select the space BG texture, go here in the inspector for the texture type, click on this drop down list and click here default, and when you do that, hit apply, and voila. So now they are, or we can use this BG image as a texture for the material. So simply now I'm gonna drag and drop it right here, and voila, automatically we have changed. You see, now this is our space. But of course, we need to resize the scale of the quad, and I'm going to rename it to BG. And select the scale of the quad. You see here X, Y, and Z. So we are going to set the X at 18 and set the Y at 10.2. Now again, X is 18. I know I said it 18 and probably you did not hear, but anyways, X is going to be 18 and Y is going to be 10.2, and voila. So now if I go in the game tab, this is what we see. Now that we have that out of the way, let us go here in assets, and I'm gonna right click and create a folder, and this was going to be our script folder. Inside of this one, I'm gonna right click, create another folder. This one going to be bg scroll script. And simply here, we are going to create a new C# script, and I'm going to call this one bg scroll. We need to attach it on the bg, so drag and drop it on the bg game object here that is in our hierarchy, and double click it and open it in Visual Studio or MonoDevelop, or I don't know, your notepad if you're using notepad to type in your code. For scrolling the background, we only need a couple of lines of code. First of all, we need the speed of the scroll, which is going to be a public float scroll speed, which I'm going to say 0.1f. This is for starters. Now, of course, we can always scroll it, or we can, when I set it to be public, so we can pump it up. So we can set the value to be higher or lower, however you prefer. We also need here a private mesh renderer that I'm going to call mesh_renderer. And this is the dude who holds the material that we need to use in order to scroll. So what I'm going to do here is change start to awake, and here I'm simply going to say mesh render is equal to get component, and we're going to get the mesh renderer component like this. And inside of the update, I'm going to call a scroll function that we still did not create. So here we're going to say void scroll. And simply what is going to happen here is that we're going to say x scroll, which is going to be the scroll for x1. And here I'm going to create a private float x scroll like this. And I'm going to say here x scroll is going to be equal to time multiplied with the scroll speed. Now time.time is the time since we started the game. You see here it says the time at the beginning of this frame. Basically, this is the time in seconds since the start of the game. And it always is going to be a higher number because it's counting the time since we started our game. And simply here I'm going to say vector3 offset is going to be equal to new vector2, and I said vector3 but I typed vector2, so vector2, and here x scroll for the offset and 0 for the y offset. And simply now mesh renderer dot shared material dot set texture offset like this. We need to pass the name of the texture plus the offset, and the name of the texture is underscore main text. This is the name of the main texture that is attached on our game object or on our BG. Now, if I go back here in Unity, let me just clear the console, voila. And now when I press the play button, we will see that the background will scroll, which as you can see indeed happens, but where are the stars going? What is happening? We are only left with this, you know, dark blue background, and the stars are gone. They should scroll to simulate an infinite background effect. What is wrong? Well, there is one more thing that we need to do. We need to go back here in assets and sprites, and for the BG one, select it. You see here, and when you select it, and here in the inspector panel, you will have these settings. So you have the default, you have 2D, you have this advanced settings here, you see? You need to click this to unfold the advanced settings, and you need to set the wrap mode from clamp to repeat. So set the wrap mode, which is the third from the bottom in the advanced, as you can see here. Click on the clamp drop down list, or actually wrap mode drop down list, set it to repeat, and set or hit here apply, and voila, we are good to go. So now if I hit the play button, we will see that it is repeating. It's not clamping, it's not in one place. It is simply repeating, and now it is working. So this is what you need to do. Bookmark this or write down a note in or for this part of the video so that you know how to set up the texture to be able to scroll infinitely. Moving forward, what is the next thing? Let's go in sprites and player, and we have our player. So we have two animations, basically spaceship and shoot. So I'm gonna take the spaceship and put it here, and voila, this is our spaceship. I know it's too big, it's not rotated how I want it. So the first thing that I'm gonna do is set the scale to 0.2 for X and Y. set the X position at -7.5, as you can see, and set the Z rotation to 90 to rotate the spaceship in the direction where it is supposed to shoot, because the enemies are going to start coming from the right side. Now, of course, we are also going to attach a couple of components. The first one being the animator component. Now, we are not going to do anything with it yet. I'm just going to attach it here for later. The next component is going to be our Box Collider 2D. So this is a 2D game in comparison to the 3D games that we did in previous couple tutorials. So make sure you attach a Box Collider 2D. Now we're going to set this is trigger checkbox, so you make sure that you check it. Let me just go here inside of our game. So this is that Box Collider. I'm going to resize a little bit. On the Y axis, I'm going to say 5.94 for the Y, and for the X 4.91. So just so that I can resize a little bit, I don't want it to cover the spaceship in whole or outside of, you see what I mean? We have these lines that are determining the bounds of the collider. So this is how I want them to be a little bit closer to our spaceship. Voila, that is that. And by the way, did I rotate the spaceship correctly? Yes, I think I rotated correctly. Yeah, this is the way that we are going to rotate. Anyways, moving forward, what is the next component we're going to attach? A rigid body. So click here and rigid body 2D. So attach it. I'm going to change this body type from dynamic to kinematic. Before I do that, let me explain what dynamic is and what is kinematic. And in order to explain, I'm simply going to run the game. So now the body type is on dynamic. You see now the ship simply fell down. If I set the body type to kinematic, from dynamic to kinematic, and I'm going to hit the play button, the ship is going to stay in one place. Simple as that. When we have a dynamic rigid body, physics, gravity, and everything is going to affect the rigid body. But if we have it on kinematic, the gravity will not affect it, but we can still affect it by forces. We can use rigid body.add force and stuff like that to move this rigid body. But if we set it on static, then we will not be able to affect it neither by gravity or by add forces. And voila, this is it. This is only what we need to do. Before I proceed to create a script, I'm gonna right click and go into and I created a new script. And what I actually wanna do, create a new folder for prefabs. And I'm going to drag and drop our player prefabs, or spaceship prefab actually. So drag and drop it here. And now I can go into the scripts and right click and folder. And this one is going to be player and player script. And here I'm gonna right click, a new C# script, and this one is going to be the player controller. So simply we're going to name in player controller, select the spaceship here in the hierarchy and drag and drop the space or the player controller, and click here to override and apply all so that this change is applied to the prefab. I'm gonna double click this and open it in Visual Studio, tag the class, and what we need in order to start moving or to move our ship. First of all, let me take this here, lower it down, voila. We need speed, so we're going to say public float speed, which is by default 5F. And we also need, and that's oblique, it's public. And we also need a minimum and the maximum Y to constrain our player. Now, what do I mean by that? Well, we will see in a second. Because if I go here and create a void move player function like this, what we need to do is the following. We are going to create a temporary variable, but first of all, we're going to get an input. So we're going to say if input.getAxis raw, and we're going to do that for the vertical axis. If that is greater than 0, that means we are going to go above. And here I'm going to say else if input get axis raw vertical is lower than 0, we're going to go below. And simply here we're going to say vector3 temp is going to be equal to transform that position. And here I'm going to say temp dot y plus equals to speed multiplied with time dot delta time. And simply we're going to assign that to our transform position is equal to temp. And here below, we're simply going to subtract. So we're going to say temp y minus equals time dot delta time and call this in the update function. Don't worry, I will explain everything in a moment. So I will explain everything in a moment. First of all, I want to demonstrate. So if we go back here, and I am going to clear the console. So go here, clear the console. I'm going to hit the play button. The get access raw will detect when we press the up arrow key or down arrow key or W or S key. So I'm pressing, what am I saying? I'm pressing S, and you see now I'm out of screen. We don't want this. And if I go here up, I'm also out of screen, out of bounds. We don't want this. We need to strict the movement for our spaceship. So for that, here below, we are going to say public float minimum Y and maximum Y. I'm going to set them as public like this, and we will add the values in a moment in the inspector panel. But what we are going to do here is we are going to test if our temp.y is greater than the maximum Y, and we will see in a moment why. Then we're going to say temp.y is equal to maximum Y. And simply here, we are going to test if temp.y is lower than the minimum y, then we're going to say temp y is equal to the minimum y. And if I go now here, how we're going to determine this? Well, we're going to simply use the spaceship. Remember now that y is at 0, but what I'm going to do is move it here up, and this is 4.3, I believe. Yes, exactly. 4.3, the maximum value. So we are going to say here, maximum y, 4.3. And for the minimum is just the negative. So here I'm going to say negative, and voila, yeah, this is the negative. So here we're simply going to say negative 4.3. And let me put it back at 0. And I'm going to hit here, apply, so that all the changes that I did here apply to the prefab. If I hit the play button now, we will see if I go up, this is the highest I can go. I cannot go above because the bounds now, the maximum y is not allowing me. If I go below, it is not allowing me to go below. Now let me go back in the code and explain. First of all, I'm going to take the highlight. So highlight, here it is, highlight tool. And I'm going to draw Unity's coordinate system. So this is y and this is x. Up on the y is positive, so it's plus. Down on the y is negative. So if we are testing here, if get access raw vertical is greater than 0, that means we are going up, because by default this will return 0 if we don't press a key. Get access raw vertical will return when we press the up arrow key or the down arrow key or W or the S key. So these 4 keys will be returned, or when we press, this will return. So if we press W or up, it will return 1. If we press S or down, it will return -1. And if we don't press it, it will return 0. So you can test that out by using print statement to print this out. So this is your assignment, and you will have a couple more assignments here in a moment. So you can use that to print it out and see. Anyways, if we press the W key or up, then this will return 1, which is greater than 0. That means we need to go up. You see, that's why here we are saying plus equals to add to the y position. And notice here, we are saying temp.y. We cannot use this in C#. We cannot say transform.position.y plus equals to speed multiplied with time.delta time. This is not allowed. You see, if I hover over, it says cannot modify the return value of transform position because it's not a variable. We need to store it here. You see, we need to store it, first of all, let me just go here. We need to store it in a temporary variable. So you see here, we have the position. Let's imagine that the position has a value of 1. We store it here in the temp. So temp has a value of 1. So we're using 1 plus equals means this. A shortcut for typing temp.y is equal to temp.y plus this right here. So instead of typing all of this here, we're simply going to say plus equals to, which will add to the value. So if temp is 1 plus equals the speed multiplied with delta time will add to it. And here we will assign it back to the original position or original value. So now this value that previously was 1 has a new value that we calculated here. And here we're testing if that value is greater than the maximum y that we have determined by simply typing here 4.3, by moving the spaceship here to see to which height can the spaceship go before we want to strict him so that it is not out of bounds, which we saw. We saw an example when we go out of bounds. We saw an example when we are not allowed to go out of bounds. We are not allowed because of this right here. And down, we are not allowed because this right here. So basically that is that. And everything that I said here applies for here except in the negative or moving down. So now when the vertical get axis raw is less than 0, that means we are going down. So we are subtracting from it. And it's the same shortcut that we showed here except for the minus. So we're subtracting from it the speed multiplied with the delta time. And then here simply we are checking if we have a lower value than y, the minimum y, then we are going to set the value to the minimum y and not allow us to go below bounds. If you're wondering why time.delta time, it is used to smooth things out. So if I do something like this, if I say speed, simply minus equals speed, and if I go and test it out, now you will see the difference and what I mean when I say smooth things out. When I hit the play button, you see now, it simply goes, you see, it's really quick. It does not go slowly. It's, you know, this is what I mean. So I'm gonna go back here and return this. Time.delta time is a difference between the frames. So this is the time it took from one frame to go to another frame. If we have 60 frames in a second, it's a very low number. Your assignment is to fix this right here. I know that I don't love hard coding things, but I'm going to do that in this tutorial. And your assignment is to put all of this in a single script using a static variable so that you can access it right here. And you will do that for everything that I'm going to do, where I'm going to use these hard code names in the project. I've been doing that in other projects, so I want also to test your knowledge to see if you've been following along. So that is your assignment for this video. Moving forward, now we can add shooting for our spaceship. But in order to do that, we will need to go back in Unity and create the bullet first because, well, we cannot shoot without a bullet. So we need to go back in assets and sprites, and for the player we will have this laser shoot. So we are going to put it right here. This is the laser shoot, or I'm going to call it player bullet because we are also going to have an enemy bullet, and I'm going to duplicate them. And one I'm going to call player bullet, another one I'm going to call enemy bullet. I'm going to take them both and put them here in the prefabs folder. So I'm gonna create a new folder for bullets. Inside of this folder, I'm going to first drag the player and then the enemy bullet. So now I can delete the enemy bullet. Later on, we will use it so that we don't duplicate it later on. That is the reason why I created it right now. So what do we need? First of all, we need to make it a little bit, well, low or smaller. Forgot the word. Anyways, we need to make it smaller because it's pretty huge in comparison to our game. So we're going to set the X to 0.3 and Y I'm going to say 0.7, and voila, this is exactly the size that is enough for the game. And where is the bullet? Let me just find it here. Here it is in the middle. So this is our bullet. The next thing we need to do is attach a box collider. So box collider 2D. It's going to be a trigger, so check the trigger checkbox. We are also going to attach a rigid body, and same as what we did for our spaceship, we're going to change it from dynamic to kinematic, and voila. We also need to create a bullet script, but let me just click here, overrides and apply to all. So let me go back here in asset scripts and right click here, folder for the bullet scripts. And here I'm gonna right click, create a C# script, almost set to C# folder. And this one is going to be called bullet script. Voila, simple as that. What do you expect? I'm pretty creative. I'm going to attach or take the player bullet and attach the bullet script on it. Let me just go here, overrides, and click it again and open it. So let me go here, double click it. What do we need in order to move our bullet? Well, we always need a couple of variables, you know that. And here I'm going to do my thing because, just because. Don't ask why, just because of that. Anyways, here we need a speed. So public float speed, which is gonna be 5f. And we also need a public float deactivate timer, which is gonna be equal to, I don't know, let's say 3f. This is what we need for now. And simply below our update function, we're going to create a void move function, not on animation move. Why? Here it is. So only move, and move will be called in the update like this. And well, move, you can assume for what we're going to use it. We're simply going to say here vector 3 temporary position is equal to transform that position, which is the current position of the bullet where it is, well, where that position is. We're going to say temp.x plus equal, so we're going to add to the x position, because if you go back here, we are shooting from the left side to the right side. You see here? So our bullet needs to go from here, see, like this here. And by the way, we are going to, as you can see here, the bullet is not visible below the enemy. So select the spaceship, and here for the rendering order for the sprites, set the order in layer for the spaceship to 2, because we do want it to be like this. So we don't want the player bullet to be visible, but they were both on the order in layer 0, so it can happen that they will be, sometimes maybe the bullet will be rendered on top of the player, and sometimes the player will be rendered on top of the bullet. But when you set the order in layer to a higher order, that means the player, the spaceship, will always be rendered on top of this game object. And if you don't know what I'm talking about, I will put a link to my sprite rendering order video. Anyways, you see, I'm shooting from the left going to the right side, and if you pay attention to the X position of the player bullet, it is increasing. You see now we have -5, 4, 0, 1, 2, 3, and it's going outside. Voila, that is why we're adding to it, and we're adding the speed multiplied with the time.delta time. Time.delta time is used to smooth things out. We saw the effect of it when we moved the spaceship up and down. And lastly, we simply say transform position is equal to temp, and voila, that is all we need to do. Now, before I attach, actually let me attach it right now. And let me attach it on the player. So our bullet script, let me go here and override. Let me just click here, override all, player bullet, select or double click on player controller. So here on top, we need to have our public game object, which is going to be the player bullet. Now we can also make it private. We can say private with the serialized field, and I'm gonna actually leave it like that because I don't want it to be public, so it is accessible in other scripts. Now, before we actually shoot it, we are going to go here and select our spaceship, and I'm gonna right click on it and go here, create an empty game object, and this empty is going to be where the bullet is going to spawn. Let me just tag it here with the red one, and I'm pretty satisfied for this here. Something like this. Yeah, I think this will do. Yeah, this is totally fine. And this is going to be where our bullet is going to be spawned. Let me click here, overrides, and apply all. And here we are going to also have a serialized field for a private transform, and this is going to be the attack point. And now we can, well, safely drag and drop all of these. Let me go here in our Unity. Come on, scroll down for the game object. Here it is, and I can call it attack point or spawning, or where the attack point is going to be spawned. So attach it right here, and for the player bullet, click on this little dot here, which will open the filter, and it's the little right here, these two dots. You see them? So you see them. Click on this one for the, and what am I doing here? Open this. Anyways, close this, not showing Windows. Click here on this little circle and select the player. Where is the player? Assets. Yeah, not in the scene, but in the assets. Select the player bullet. Here it is. So select the player bullet, and that is the one that is attached. Let me just go here and overrides and apply all, and voila. So what is the next thing that we need? Well, we need to limit how many times our enemy can shoot, so that we don't do something like this. So we're not gonna do something like void and attack like this, and go here, input, or actually if input.get key down is key code K. I'm gonna say K, you can say whatever, you can press, like, have any key code to be pressed for you to shoot. Then simply we need to say instantiate player bullet at the attack point position using quaternion.identity, and voila. So if we go and put that in the update attack, I like to do things like this. I like to show you first a potentially wrong way. This is not necessarily the wrong way, depending on what you want to achieve. but I have the way that I did it that I think is correct for this video, so I'm going to show you the one that is not correct. So you see here, yeah, we can shoot. But the problem is, as you can see, we have a couple of problems. First of all, whenever I press the K key code, we will shoot. So whenever I press it, I'm pressing and holding it will not do, so we are using here if input get key down. As you can see, get key down. So it will only detect when we press it down. But the problem is the following. I'm pressing, you see, and we are shooting for as long as I'm pressing, and this is not giving any chance for our enemies to avoid the attack. The second problem is this. You see the bullet, the first bullets they're still in the game. We don't want that. They're still in the game, and potentially this can hurt memory over time depending on how many bullets you have. So let's first strict the shooting. Here I'm going to create a public float attack timer, which by default I'm going to say 0.35. It's a public one and it's underscore timer, and it's public one, which means we can change the value. It's not private. The next we're going to have a private float current attack timer. This is the current time for the attack. We will see that, don't worry. And we have a private bull can attack. Voila. So what do we need to do with this? Well, in the attack right here, I'm going to take this. And in the attack, the first thing that we're going to say is attack timer plus equals to time.delta time, you see? And what we need to do is also store the current attack in the start so that we know that what is the value of the current one. So here we're going to say current attack timer is equal to the attack timer. And now that we are adding to the attack timer delta time, we can test if the attack timer is greater than the current attack, you see? And let me just tag here, attack. Now when this happens, we can say attack or can attack is equal to true. And below, we are going to say if our input get key down key code K is pressed, if can attack is true, which means we can attack, then we are going to attack. So we are going to instantiate our laser, and we're also going to say can attack is now false, and the attack timer reset it back to 0. And below here we will play the sound effects, which will come later on. So you see what we're doing here. If you watch my previous tutorials about first-person shooter, I mean, what am I saying? If you watch, surely you did. Anyways, attack timer plus equals time.delta time. Time.delta time, as I said, is a very small value. So it's a very small value that we are going to use to determine or to add to the attack timer. So what is the issue here? The issue is that we're adding that value to the attack timer. Eventually it will get to the value that is greater than the current attack timer. So you get my point? The current attack timer has a value of, you see, 0.35. This is what we're doing. We are storing, you see here, the attack timer, we are storing it in the current attack timer. So then we're adding to the attack timer time.delta time, which eventually will give it or get it to a value greater than the current attack timer, which means can attack will be equal to true. When we press here the K and can attack is true, we will attack, so we will instantiate it. But then here can attack is false and reset the attack timer, you see? Let's test it out and you will see now what I'm talking about. So when I go here, and pay attention now, when I press the K, you see I'm pressing repeatedly. I'm pressing it repeatedly, but you see I can shoot, and you see after a couple of these seconds, then I can continue to shoot. If I set here, let me say attack timer is 1. Pay attention now, I'm going to press and press and press. So I'm shooting, and you see the difference between the shoots. I'm pressing, this whole time I'm pressing the button. This whole time I was pressing the button, but you saw the difference between the bullets, how far one went before the other was spawned. Now I'm going to put it back to 0.35, and let me go here and hit apply all to save the change to the prefab. So this is how we can strict our player from shooting, like crazy. So simply have a variable, and we're going to add to it time.delta time. When that variable is greater than the current attack timer, then we will say can attack is true. When all that happens, reset that value to be 0 again so that we cannot shoot right away. So one issue is fixed. Another issue is in the bullet script that our bullet is not being deactivated. What is up with that? Well, that can be fixed easily. We can simply say void deactivate game object, and simply here we can say game object set active is false, simple as that. And in the start we can simply say invoke, and the invoke function is built into mono behavior, and simply we can use it to invoke a function with the name in the given time interval. So deactivate timer is the given time interval. What this will do, it will call the function with this name after this many seconds. Here we set it to be equal to 3, which means if I go back now and let me shoot a couple of times and go back into the scene view so that you can see that. So I'm shooting 1, 2, 3. Pay attention now for the bullets. You see now? They will go outside. So let me shoot 1, 2, 3. Pay attention for the bullets. They will go away. You see? Maybe we need to leave them a little bit more. The attack timer for the bullet. Let me go here in the prefabs and bullets and player bullet. Open prefab. Maybe the deactivate timer will be set at 4. Because if I go here, we need to allow it to go outside of these bounds. We need to allow it actually to go outside. What am I doing? Let me just go back here again. So shooting, shooting, shooting. You see now when it goes outside, it will deactivate. You see, bam, bam, bam. You see all 3 have deactivated. So this is what we also need to do. This is how you can prevent them from having, an impact on your memory, because a game object that we don't need in the scene anymore, it served its purpose. We shoot, the bullet is flying, so on and so forth. So we served its purpose. We simply need to deactivate it. So simply deactivate it because there is no need for it to be in the game to take up the memory, because the game object that is deactivated, the scripts that are attached on it will not be executed. So all the scripts that are attached on the specific game object, when you deactivate it, those scripts will not run, and that way we will save memory. Moving forward, we can now add the enemy in our game. So we need to go into sprites and select the enemy folder and attach this one. And this is the enemy. This is the enemy. This is going to face this one, and I don't care. But I'm just kidding. Anyways, what we are going to do, I'm first of all going to rename this one to simply enemy. I'm going to take X scale and set it to 0.2 and Y scale set it to 0.2. The Z rotation, I'm going to say 90 degrees, and voila, this is our enemy. We are of course going to set the order in layer for the enemy at 2. I'm going to click on add component and attach a box collider 2D. And of course, let me go here in the scene and resize a little bit, because this is not how I want it to be. That's pretty large. So I'm going to say 4.91 for X, and probably we can lower it a little bit more. Yeah, this can be for the X. This right here. And for the Y, 5.94. Yeah, this is totally okay. Maybe just move it offset a little bit on the y-axis, something like this. Yeah, this is okay. This is fine. Another add component or component is going to be a rigid body 2D, and we're going to set it from dynamic to kinematic. So make sure that you do that as well. Now, before we proceed to do anything, I'm also going to attach an audio source component. So audio source component here, we'll use it later on. But what I'm also going to do is create animations for our enemy. So selecting the enemy, but first of all, going here in assets and creating a folder for animations. So animations. Inside of here, right click and create a new folder. This one is going to be enemy animations. And now selecting the enemy and going here into the animation, I'm going to create a new animation, and I'm going to call this one idle, or yeah, idle. We can call it idle. So here I'm going to save, and let me just see here, animator, and we have with the enemy, yeah, controller, that's okay. Now here for the animation itself, I'm going to simply attach, so script, sprites, enemy, the two enemies. So enemy 1 and enemy 2, I'm going to simply attach them here. So if we go into our scene tab and select the enemy to preview that, so I'm going to, actually we cannot preview it here. Let me see, can I click it? Yeah, but does it preview? No, we need to select it like this, and now it previews it. You see, now it is previewing the enemy. So yeah, this is what we want. Now another, actually we need to rotate the enemy, I believe, negative 90. Is it negative 90? No, it's actually 90. Yeah, we're going to leave it like this. Anyways, We also need another animation. So here I'm going to click on this drop down list for the idle and click here, create new clip. And this one is going to be destroy. So this is simply the destroy animation. And for this one, let me move this up here again, the animator. We need to go into the explosion. This is what we need. This is a sprite sheet. So we need to select it and go here into the sprite mode single and check the multiple. So change it from single to multiple and click here apply. So these changes apply, and now I can open the sprite editor and I can slice all of this here by clicking on the slice at the top left corner. If you did not saw it, it's right here. Now I'm not sure if you can see it because my highlight tool, let me move it down. So this is the slide that we need to click. So click on that one. It will open another window where you can slice and click the slice button here and voila. So now we have all of these animations. You can see they are all sliced pretty nicely. And yeah, it's totally fine. So what I'm going to do is press the hit apply button here and voila. So now we have the explosions. I'm going to click on the drop down list to unfold all of this and select all these explosions. As you can see, pay attention here at the bottom right corner. If I move these explosions, see from one image to another, you see what we have. So this is what we have. This is that explosion. And simply select all of these and attach them here in the animation. Voila. We are good to go. Now I can go here and I can preview that, you see. And actually we don't see it because it's very small. So let me go here for the enemy. You see if I hover over, you see actually we cannot see it because it's small, but here now you can see it. What we need to do to make it a little bit larger is to go into the project and select this explosion. You see here this pixel per unit, it's set at 100. Now this means how many Unity pixels or how many pixels will be one Unity unit. We have this image as a 500 by 512 by 512. That means that every 100 pixel in that image will be a one unit in Unity. Unity's one unit is this cube. Do you see this cube? So this is one Unity's unit. So what we can do here is we can pump up that value. So you can say 20, which means now 20 pixels. I'm going to hit apply, which means now only 20 pixels out of 500 will be one Unity unit. So if I go here and preview this animation now, you see it's a little bit larger. And I can even go back and set the explosion to maybe 10. So 10 pixels per unit, hit apply, go back here in the animator, and voila. You see now how clearly we see that animation. And basically this is what we need. So we need here the idle and we need here the destroy. And we can go back here in our scripts now, but before that, well, actually I'm going to attach the script anyway. So I'm going to go here in the scripts, right click and create a new folder for enemy scripts and attach the script. Then I'm going to save the enemy as a prefab. So go here, right click, C# script, and this is going to be our enemy script and attach it. So attach that script on the enemy game object. And now I can go into the prefabs and I'm simply going to drag and drop the enemy right here. So let us open the enemy script and let us do some coding. So what do we need for the enemy script? Before we can do that, you see the red lines that I have. I will need to restart my Visual Studio. I mean, why not? Why should not Visual Studio torture me with why? I mean, I don't know. Anyways, let me just double click and open it. This happens probably because my computer is open for too long. I don't know. Maybe because I'm recording this and opening this as well. I'm not sure. The important thing is that you can simply close it and open it and voila, you are good to go. So what do we need for the enemy script? As always, you know that we need a couple of variables. First one will be the speed. So public float speed is equal to 5. We will also need the public float rotate speed. Now the rotate speed is going to be equal to 50.